Alright, so for this problem, we're going to be solving for the Laplacian of t to the 7 over 2. The reason we can't use previously done methods is it's not of exponential order. It grows too quickly as it goes to infinity. But using the gamma function, which we're given here for 1/2, which is equal to the square root of pi, we can use this to solve. So here's a kind of a formula that we can use to solve these types of problems. So the Laplacian of t to the power of n is equal to the gamma function of n plus 1 over s to the power of n plus 1. Alright, so when we write this out in terms of our own equation that we're trying to solve for, we get the gamma function of 7 over 2 plus 1 over s to the power of 7 over 2 plus 1 is equal to our Laplacian that we're trying to find of t to the power of 7 over 2. Now, we run into a problem that we didn't for the other one up there that was a little bit easier, in the sense that this gamma function they give us isn't the gamma function we're trying to find. But we can use a rule, to transform this gamma function here into a method that we can go and it'll be like a constant times this gamma function. So this rule that we're using is that the gamma function of r plus 1 is equal to r times gamma r, which is equal to r times r minus 1 times gamma r minus 1, and this goes on to infinity. So you can use this to kind of just keep subtracting through. So like for our example, we're going for the gamma function of 7 over 2 plus 1. Well, if you subtract 1 from this inside term, you can then write it like this. So it's 7 over 2 times the gamma of 7 over 2, because we just subtracted 1 here. It's the same as what's going on up here, but it's just with our variables plugged in. And then we can do that kind of ad nauseum until we get, good lord, my roommates, until we can get this 7 over 2 to equal, or the 7 over 2 plus 1 to equal 1/2. So we're just going to keep subtracting by 1. And that's because we know the gamma function of 1/2. So, alright, zooming out a bit. So we're going to have to do this step back like 4 times. So this is the first times one you can see, and then times, and there's a pattern that you can make out as it goes along, times the gamma function of 7 over 2 minus 3, which is just 1/2, which is what we need to solve this problem. Kind of zooming back out, what you'll end up getting is just these constants out here multiplied by the gamma function of 1/2, which is a known value, is equal to the gamma function of what we originally had up here. Oops, sorry, blurry. Up here. We can then plug this new value in for our Laplacian. So since we know this in terms of things that we know now, we can just write out that the Laplacian of t to the power of 7 over 2 is equal to all these numbers times each other times the gamma of 1/2. Gamma 1/2 is given right up here, over s to the power of 9 over 2. And then when you solve all that out, it's just going to be this.